session.
Wham! And we're live.
Somehow appropriate for momentum. Anybody here not have a quiz? Boy, let's interrupt that recording. So now that I've got everybody up to speed. Hey, Manny, are you my favorite student? No. Who's my favorite student, Manny? Good old Ann. You guys will put an omit for your score. You missed out on a chance to make some mistakes. The first quiz was all about impulse, change of momentum, and force times time. This is about collisions and explosions, so now I'm going to be using the law of conservation of momentum. A hockey player of mass 72 kilograms is skating due north. You know, anytime they give me compass directions, it's worth doing that. He collides with another player moving south. After the collision, the first player moves off. What's the final velocity of the second player? Is there a collision? This is a job for momentum. Before the collision, what's moving? Mass 1, mass 2, or both? Both, stuck together, or separate? Separate. Wham, they collide. After the collision, what's moving? Mass 1, mass 2, or both? Both. Stuck together or separate? Separate. Okay. Sasha, you can go. It's going to be M1V1 initial, M2V2 initial, M1V1 final, M2V2 final. What am I trying to get by itself? They want the final velocity of the second player. They want that by itself. I think what I'm going to do is I'm going to minus this to this side and then divide by M2. It's a little longer than some of the ones I've dealt with, but okay. V2 final. Well, don't forget the 2, Mr. Dueck, just so you don't get mixed up. V2 final is going to be M1 V1 initial plus M2 V2 initial minus M1 V1 final, all divided by M2. It's going to be M1 V1 initial. What's mass 1? 72? What's V1 initial? 7.5? Plus, what's mass 2? 65. Shaq there. I don't know. I think it's Shaq and then Reed. Good memory. Hey, what's V2 initial? Yeah? Again, key idea. I'm going to have to go negative. If you miss the negative, it's going to cost you a half mark. Minus mass 1, 72. And V final is also negative because it says south. All divided by 65. Here's hoping that works out to a nice answer. V2 final equals bracket 72 times 7.5 plus 65 times negative 8.1 minus 72 times negative 1.3. Close bracket. That looks good. Divided by 65. Do you get 1.65? Direction. North. 1.65 meters per second. North. I did say magnitude and direction. Yes, I did. Okay, if you got that right, you get 3 out of 3. Otherwise, I'd probably go 1, 2, 3, 4, 5. Hey, there's 6 lines. I'd give you half mark for that, half mark for that, half mark for that. I'd probably give you a half mark for that, half mark for the magnitude, and a half mark for the direction. There's 6 marks. something like that. A 52-gram ball is dropped, hits the ground. After impact, it rebounds. If the impact takes, what's the average force? Okay, now they're talking about force, so I think I'm going to say this. Force times change in time equals change in momentum. I think I'm going to say force equals change in momentum divided by time, where change in momentum is going to be final minus initial. This is going to be mv final minus mv initial divided by time. What's the mass? 0.052. What's v final? Sorry? Okay, if you decide negative, you're going to be up is negative. A little weird, but that's okay. How many of you said up was negative? How many of you said up was positive? So I'm going to go up positive, and I'll let you do the translation, okay? So it's going to be positive 6.2 minus 0.052. But what that means is V initial has to be negative 8.2. Half mark off if you missed that, divided by 0.15. You're going to get a force of 0.052 times 6.2 minus 0.052 times negative 8.2, close bracket, divided by 0.15. That looks good to me. Do you get 4.99? That's the magnitude. Direction. I got positive. Which way did I say was positive in my question? Up. You would have gotten negative, yes, and you would have still said up. So I'm going to say 4.99 meters per second up. 3 marks. 1, 2, 3, 4, 5. Sure, that works. Half. If you got it right, 3 out of 3. Otherwise, a half mark for that. Half mark for that. Half mark for that. Half mark for successfully sticking in the numbers. Half mark for the magnitude, and a half mark for the direction. Sorry? It's newtons, Mr. Dueck. That's what I said. Sorry. That was a messy N, I realized. That's a much neater N now, right? Wow. I haven't done B with you. I made it worth 1 mark. I fully expect that you have enough physics that you can handle B. Anthony, what does B want me to find? What's change in anything? Oh, so I guess I'm going to go like this. The change in kinetic energy is going to be KE final minus KE initial, which is going to be a half mv final squared minus a half mv initial squared. Okay. 0.5 mass, 0.052. V final, 6.2 squared minus 0.5, 0.052. V initial. Mr. Dueck, why didn't you say negative 8.2? Energy is a scalar. By the way, even if I put a negative in there, what would happen when I squared that negative? What's a negative squared? So that's one way also that's telling you, I think energy is a scalar because you lose your direction anyways. I think I'm going to get a negative answer. That's okay. 0.5 times 0.052 times 6.2 squared minus 0.5 times 0.052 times 8.2 squared. Is that right? Looks good. Do you get negative 0.75 joules? Now, this negative is not a direction. It's saying you lost kinetic energy. Well, yeah, I've bounced things off the floor. Do they ever come back higher than when you drop them? Well, we did a lab where they did. But why in that case? Because we had added energy to the system. But if you don't add energy to the system, they're not coming back higher. In fact, they're not even coming back the same height. The only way they would come back the same height is if they were 100% efficient. We said that sadly doesn't happen in our universe. You're going to lose kinetic energy. 1 mark. All or nothing for that one. Let's shoot Bob in the pendulum. A bullet of mass that is traveling at 430 meters per second. It strikes a wooden pendulum bob, sticks inside. How high will it go? So this has two parts. The collision and the swing. And what we're going to do to find how high is we're going to find how fast it's moving after the collision. We're going to say all the momentum before equals all the momentum after. We're going to say before the collision, what's moving? Mass 1, mass 2, or both? Mass 1. And because I'm running out of room, instead of writing momentum, I'm going to go mass 1. And momentum 1 initial is M1, V1 initial. I'm going to jump straight to that line. When they collide after the collision, stuck together, it's going to be M1 plus M2 V final. Jeff, V final is going to be M1 V1 initial divided by M1 plus M2. It's going to be 0.008 430 divided by 0.008 plus 0.75. 0.008, oh, too many. 0.008 times 430 divided by bracket 0.008 plus 0.75. And I get 4.5382. I'll write 4.54, but I'll keep this on my calculator. And that one is meters per second. Now let's swing up. Did I say swing? Start on the ground, come to a stop. In fact, we've seen this a few times before now. A half m both, v initial squared equals m both, g h final. Gone, gone. We want h. H is going to be v initial squared divided by 2g. It's going to be 4.54 squared divided by 2 times 9.8. It's going to be that number squared divided by bracket 2 times 9.8. Does that work? Do you get 1.05? Meters. So if you get that, you get 4 out of 4. Otherwise, 1, 2, 3, 4, 5. I'd probably go something like this. Half mark for that. Half mark for that. Half mark for that answer. Gets you 1.5. 2 marks. 2.5. 3. 3.5. 4 marks. I think that works. Something like that. I don't know. If you're not sure, ask me to look at it. Last one. Wow, there's a yawn. Okay, now they've given me the height, and they want to know what's the incoming speed. Now, I'm going to start with the swing, where I know where I know 0, 0, where I know a half m v initial squared equals m g h final. Which m? It is the mass of both, but they're going to cancel anyhow, so what do I care? Then I'm going to get v initial is going to be 2 g h final square rooted. I'm going to get v initial is going to be 2 9.8 0.1, not 10, square root 2 times 9.8, 9.8 times 0.1, square root. Oh, nice, 1.4. How's that going to help me? Well, over here, I know there's a collision. Before the collision, bullets moving. After the collision, inelastic, stuck together. We want V initial. Okay, I guess V1 initial is going to be M1 plus M2 V final divided by M1. It's going to be 0.007. 007? Yeah, hey, yeah, okay. Bullet question? Oh, fine. Plus 1.5. I wish I'd planned that. I really didn't, but note to self, I will plan it. Say I planned it next year. V final 1.4, all divided by 0.007. Wow, Mr. Dueck, wake up. You get 301.4? Which is about the speed of a speeding bullet. I'm okay with that. 301 meters per second. If you got that, 4 out of 4. Otherwise, well, I noticed there's 1, 2, 3, kind of 4 lines here. 1, 2, 3, kind of 4 lines here. I'd probably go a half mark for each line-ish. If you're not sure if you need to come lawyer with me, you can. Do not knee me. Hand the quizzes in. Normally I would collect them. Will I see you between now and the test? No, I'm going to be away, amazingly. Again, by the way, the only thing that could drag me away is conflicts or field trips. And so I'm coaching, I have to be away for playoffs. Instead, can the person at the end of each row rip out a piece of paper, write your name and your quiz score, pass it down. The next person writes their name and their quiz score, pass it down. Next person writes their name and their quiz score. Send them towards the middle and I'll come grab the scores.